Imagine an object that cannot be seen. It emits no light. It has no surface. And yet its gravity is so powerful that even light itself cannot escape its pull. This object is a black hole. For decades, black holes felt distant and abstract to us. We imagined them far away, deep in the centers of galaxies, millions or even billions of light years from Earth. Strange cosmic monsters existing far beyond anything that could ever affect our lives. But reality turned out to be much closer. Somewhere within our own galaxy, the Milky Way, among hundreds of billions of stars, there exists a black hole that is currently the closest known one to Earth. Cosmically speaking, it is nearby, close enough to raise a natural and unsettling question. Is it dangerous? The idea of a black hole near Earth triggers a deep, instinctive fear. Black holes are often portrayed as cosmic vacuum cleaners, objects that roam through space, swallowing stars, planets, and entire solar systems without warning. Movies and science fiction have taught us to fear them. They bend space violently. They tear matter apart. They represent destruction on a scale that feels impossible to control. But science tells a very different story. In reality, black holes are not hunters. They do not chase planets. They do not grow endlessly, consuming everything around them. Most black holes are surprisingly quiet. They sit in space, obeying the same laws of gravity as every other object in the universe. And unless you come extremely close to one, a black hole can remain almost completely unnoticed. That is what makes this discovery so fascinating. The closest known black hole to Earth is invisible. It emits no radiation. It shows no violent activity. If astronomers had not carefully measured the motion of nearby stars, we might never have known it was there at all. And yet it exists, silently orbiting within our galaxy, unseen, unfelt. So what does it actually mean for us? How close is close in cosmic terms? What do we really know about this nearby black hole? And how much of what we fear is based on myth rather than physics? And finally, the most unsettling question of all. What would happen if a black hole somehow appeared inside our own solar system? To answer these questions, we need to separate fear from facts, fiction from reality, and cinematic imagination from real astrophysics. Because the truth about black holes is far more subtle and far more fascinating than the stories we usually tell about them. To understand whether the nearest black hole poses any danger, we first need to answer a simple question. Where exactly is it? The closest known black hole to Earth is called Gaia BH1. It was discovered in 2022 using data from the European Space Agency's Gaia spacecraft, a mission designed to precisely measure the positions and motions of stars in our galaxy. Gaia BH1 is located at a distance of approximately 1,560 light-years from Earth. In everyday terms, that sounds unimaginably far. But on a galactic scale, this distance is considered surprisingly close. The Milky Way galaxy is about 100,000 light-years across. So Gaia BH1 lies well within our local galactic neighborhood. This black hole is not isolated. It exists as part of a binary system paired with a star very similar to our Sun. The two objects orbit a common center of mass, locked in a slow, predictable gravitational dance. What makes Gaia BH1 unusual is not its size, but its behavior. The black hole has a mass roughly 10 times greater than the Sun, which is typical for stellar mass black holes formed from the collapse of massive stars. However, unlike many known black holes, Gaia BH1 is not actively feeding. It is not pulling large amounts of gas from its companion star. It is not surrounded by a bright accretion disk. It does not emit powerful X-rays. In fact, Gaia BH1 is almost completely dark. If its presence were not revealed by the motion of its companion star, we would have no direct way to detect it. This makes Gaia BH1 one of the most quiet black holes ever discovered. Its companion star follows an orbit that cannot be explained by visible matter alone. The star moves as if it is being pulled by an invisible object. An object with enormous mass but no light. This invisible mass is what identifies Gaia BH1 as a black hole. Importantly, Gaia BH1 is not moving toward us. It follows a stable orbit around the center of the Milky Way, just like our own solar system does. Its trajectory poses no known threat to Earth. There is no scenario in which it suddenly changes course or drifts into our region of space. From a gravitational perspective, Gaia BH1's influence ends long before it reaches our solar system. At a distance of more than 1,000 light-years, its gravitational pull on Earth is effectively zero. In fact, the gravitational effect of nearby stars is far stronger than that of Gaia BH1. So while the phrase nearest black hole may sound alarming, the reality is far less dramatic. Gaia BH1 is close only in astronomical terms. In practical terms, it is safely distant, quietly orbiting its companion star, far beyond any influence on our planet. Black holes are invisible by nature. They emit no light, reflect nothing, and cannot be photographed directly in the way stars or planets can. So how can we be certain that Gaia BH1 is truly a black hole? The answer lies not in what we see, but in what we measure. Astronomers detect black holes by observing their gravitational effects on nearby objects. Gravity leaves signatures, subtle but unmistakable, in the motion of stars and gas. In the case of Gaia BH1, scientists focused on its companion star. This star appears ordinary at first glance. It emits light, follows a stable path through space, and shows no signs of extreme activity. But when astronomers carefully measured its motion, something didn't add up. The star was orbiting an object that could not be seen. An object with significant mass. Too massive to be a planet. Too compact to be a cluster of stars. Using Gaia's extremely precise measurements, scientists were able to track the star's movement over time, down to tiny shifts in its position in the sky. This technique is known as astrometry, the science of measuring stellar positions and motions. By analyzing the shape and speed of the star's orbit, astronomers calculated the mass of the invisible object it was circling. The result was clear. The unseen companion had a mass about 10 times that of the Sun. Yet it emitted no detectable light. There are very few objects in the universe that fit this description. It could not be a white dwarf. Those are too small in mass. It could not be a neutron star. Even the heaviest neutron stars fall short of this range. That left only one possibility: a black hole. What makes Gaia BH1 especially important is that it represents a new kind of discovery. Most black holes we know about were found because they are active, feeding on nearby matter and emitting intense X-rays. Gaia BH1 does none of that. It is a dormant black hole, quiet and stable, revealed only by the motion of a single star. This suggests something remarkable. If Gaia BH1 exists so close to Earth and remained hidden for so long, there may be many more black holes like it in our galaxy, silent, invisible, and undetected. Current estimates suggest that the Milky Way may contain tens of millions of stellar mass black holes. Most of them do nothing dramatic. They simply exist. They orbit the galaxy, interact gravitationally with their surroundings, and remain unseen unless they reveal themselves through motion. Gaia has given us a new way to find them. By watching how stars move, we can uncover objects that would otherwise remain completely hidden. Black holes have captured the human imagination for decades. They appear in movies, novels, and documentaries as unstoppable forces of destruction. But much of what we think we know about black holes comes not from science, but from fiction. To understand whether black holes are truly dangerous, we need to separate myths from reality. Let's begin with the most common misconception: the idea that black holes endlessly suck in everything around them. In reality, black holes do not behave like cosmic vacuum cleaners. They do not pull objects in from great distances. A black hole's gravity follows the same rules as the gravity of any other object with mass. If you replaced the Sun with a black hole of the same mass, the planets would continue orbiting almost exactly as they do now. The only difference would be the absence of light and heat. Another widespread myth is that black holes are constantly growing, consuming matter without limit. In fact, most black holes grow very slowly, if they grow at all. Many spend billions of years in a quiet state, not feeding on surrounding material. Gaia BH1 is one such example. It is not actively pulling matter from its companion star. It is stable, calm, and largely invisible. There is also the belief that black holes are extremely rare, something so exotic that encountering one nearby would be nearly impossible. But modern astronomy suggests otherwise. Black holes form when massive stars collapse at the end of their lives. Given the number of massive stars that have existed in our galaxy, it is likely that the Milky Way contains millions of stellar mass black holes. Most of them simply go unnoticed. They do not glow. They do not emit radiation. They do not announce their presence. Another myth is that approaching a black hole means instant destruction. While it is true that crossing a black hole's event horizon would be fatal, this only happens at extremely close distances. Far from the event horizon, a black hole is no more dangerous than a star of the same mass. The fear surrounding black holes often comes from how little we can observe directly. They represent regions where our current understanding of physics breaks down. But that does not make them monsters. It makes them laboratories, natural experiments created by the universe itself. Understanding black holes requires us to let go of dramatic imagery and focus on evidence. When we do, a very different picture emerges. Black holes are not agents of chaos. They are a natural consequence of stellar evolution. Silent, stable, and far less threatening than we are often led to believe. To understand what a black hole can and cannot do, we need to talk about gravity. Gravity is the key to nearly every fear associated with black holes. It is often imagined as an irresistible force, growing stronger without limit. But gravity does not work that way. A black hole does not create a new kind of gravity. It does not bend space more aggressively at large distances than any other object of the same mass. From far away, the gravitational pull of a black hole is indistinguishable from that of a star. This means that a black hole with the same mass as the Sun would influence the planets in exactly the same way. Earth would continue to orbit along the same path. The Moon would still circle Earth. The solar system would remain gravitationally intact. The difference between a star and a black hole is not the strength of gravity at a distance, but how concentrated that mass is. In a normal star, mass is spread out over millions of kilometers. In a black hole, the same mass is compressed into an incredibly small region. This is why black holes are dangerous only at close range. As an object approaches a black hole, the difference in gravity between its near side and far side becomes extreme. These are called tidal forces. Tidal forces stretch objects, pulling them apart in a process often described as spaghettification. But this effect only becomes catastrophic when an object gets very close to the black hole. Far beyond that region, space is calm. Planets, stars, and spacecraft can orbit a black hole safely, just as they orbit stars. This is not a theoretical idea. We observe stars orbiting supermassive black holes at the centers of galaxies, including our own. These stars complete stable orbits for thousands of years. The presence of a black hole does not automatically mean destruction. What matters is distance. This is a crucial concept when discussing danger. A black hole is not dangerous because it exists. It is dangerous only if something comes too close. In the vastness of space, those distances are rarely crossed. Black holes are among the most famous, and at the same time, most misunderstood objects in the universe. Much of what we believe about them comes not from science, but from movies, television, and science fiction. So now it's important to clearly separate myths from facts. The first and most common myth is that black holes suck everything around them inward. In reality, this is not true. A black hole is not a cosmic vacuum cleaner. It does not pull objects from great distances more strongly than any other object with the same mass. At large distances, the gravity of a black hole is no different from the gravity of an ordinary star. The second myth is that black holes wander through the universe, destroying everything in their path. In reality, black holes move along stable orbits. They obey the same laws of physics as stars, planets, and galaxies. The nearest known black hole, Gaia BH1, is not moving toward us. It is not changing its direction. It calmly orbits the center of the Milky Way. The third myth is that black holes are constantly growing and will eventually consume everything. In fact, most black holes hardly grow at all. For a black hole to increase in mass, there must be a large amount of nearby matter, gas, dust, or a companion star. If none of this is present, a black hole can remain unchanged for billions of years. Gaia BH1 is exactly such a case. It is quiet, inactive, and almost invisible. The fourth myth is that black holes are extremely rare. In reality, they may be very common. Over billions of years, millions of massive stars have died. In the Milky Way, many of them collapsed and left black holes behind. Astronomers believe that our galaxy may contain tens of millions of black holes, most of them simply remain unseen. And finally, the fifth myth, that anything near a black hole is instantly destroyed. In reality, everything depends on distance. Danger appears only when an object approaches extremely close to a black hole. That is where tidal forces become strong enough to stretch and tear matter apart. At safe distances, objects can orbit a black hole stably, just as they orbit a star. Black holes are not monsters. They are extreme expressions of the same physical laws that govern the rest of the universe. And the more we understand them, the less fear remains, and the more wonder takes its place. Let's consider a scenario that sounds catastrophic at first, but turns out to be surprisingly calm. What would happen if the sun was suddenly replaced by a black hole of the same mass? The answer often surprises people. From a gravitational standpoint, almost nothing would change. The planets would continue orbiting in exactly the same paths as before. Earth would not spiral inward. It would not be pulled apart. The moon would remain bound to Earth. The solar system would remain stable. But something far more important would disappear. Light. About 8 minutes after the transformation, the last sunlight would reach Earth. Then the sky would go dark. Without the sun's radiation, Earth would begin to cool almost immediately. Within days, global temperatures would drop rapidly. Within weeks, photosynthesis would stop. Plants would die. Food chains would collapse. Within months, the average surface temperature would fall below freezing. Over centuries, the oceans would slowly freeze from the surface downward. Life on Earth would not end instantly. Some microorganisms could survive deep underground or near geothermal heat sources. Humanity might persist for a time, using nuclear power or geothermal energy. But the planet would no longer be hospitable. The destruction would not come from gravity. It would come from the loss of energy. This distinction is important. The black hole itself would not attack Earth. It would simply fail to provide what the sun once did. This scenario highlights a key truth about black holes. They are not inherently violent. They do not destroy worlds by pulling them in. They destroy environments by removing sources of light and heat. Now let's explore a more unsettling scenario. What if a black hole entered the solar system, but the sun remained exactly where it is? At first, nothing dramatic would happen. If the black hole were located far from the inner planets, its gravitational influence on Earth would be minimal. From a distance, a black hole behaves like any other massive object. The immediate effect would be subtle. Over long periods of time, the presence of an additional massive object could begin to alter the orbits of planets. These changes would be slow, measured in thousands or even millions of years. The solar system would gradually become less stable. Some planetary orbits might become more elliptical. Others could shift slightly inward or outward. In extreme cases, planets could eventually be ejected from the solar system entirely. But this is not an instant catastrophe. There would be no sudden destruction, no immediate collapse. The danger of a black hole in the solar system comes from long-term gravitational interactions, not sudden violence. The most serious risks would occur if the black hole passed close to a planet. A close encounter could dramatically distort an orbit, potentially sending a planet onto a collision course with another body. Still, such encounters are extremely unlikely. Space is vast, even within the solar system. The distances between objects are enormous. For a black hole to enter the solar system and pass close to Earth would require a highly improbable chain of events. In most realistic scenarios, the effects would be slow and indirect. Astronomers model these situations using simulations, and the results are clear. The solar system is more resilient than we often assume. A black hole passing through the outer regions would likely leave behind only subtle changes detectable over geological timescales. Now we reach the most extreme and unsettling scenario. What would happen if a black hole came dangerously close to Earth, not entered the solar system, not passed beyond the outer planets, but approached our planet itself? In this case, the threat would be very real. The danger would not come from Earth being pulled in, like an object falling into a drain. Instead, it would come from tidal forces. As a black hole approaches, its gravitational pull becomes dramatically stronger on the side of Earth facing it than on the side facing away. This difference in gravity would begin to stretch the planet. At first, the effects would be subtle. Tectonic activity would intensify. Earthquakes would become more frequent and more powerful. Volcanic systems could destabilize. As the black hole moved closer, the tidal forces would increase rapidly. The solid structure of the planet would no longer be able to hold itself together. Earth would begin to deform, stretching along the direction of the black hole. Eventually, the planet would be torn apart before ever crossing the event horizon. This process would not be instantaneous, but it would be inevitable. Oceans would rise into massive tidal bulges. The crust would fracture. The planet would be pulled into a stream of debris. This destruction would occur long before Earth was swallowed. It's important to understand that this scenario requires an extraordinary coincidence. A black hole would need to pass extremely close to Earth, far closer than any known object ever has. There is no known black hole on such a trajectory. None are moving toward us. None are predicted to enter the inner solar system. The nearest known black hole, Gaia BH1, is more than 1,000 light-years away. At that distance, its gravitational influence on Earth is effectively zero. This scenario exists only as a thought experiment, but it reveals something important. Black holes are not dangerous because they exist. They are dangerous only at very close distances. And the universe is vast. After exploring every scenario, from distant black holes to the most extreme close encounters, we can finally answer the central question. Should we be afraid of the nearest black hole? The scientific answer is simple. No. The closest known black hole to Earth, Gaia BH1, is far too distant to pose any threat. It follows a stable orbit within the Milky Way. It is not moving toward us. It is not interacting with our solar system in any meaningful way. Its gravity does not reach us. Its presence does not affect Earth's orbit, the Moon, or the Sun. In fact, countless stars closer to Earth have a far greater gravitational influence than Gaia BH1 ever could. The fear surrounding black holes comes from misunderstanding. They are not cosmic predators. They do not wander the galaxy. searching for planets to destroy. They are remnants of dead stars, obeying the same physical laws as everything else in the universe. Most black holes are silent, invisible, and completely harmless from a distance. Ironically, black holes may be more important as tools for understanding the universe than as sources of danger. They allow us to test the limits of physics. They reveal how space and time behave under extreme conditions. Without black holes, our understanding of gravity, galaxies, and cosmic evolution would be incomplete. The universe is not as hostile as it often appears. It is vast, structured, and governed by consistent laws. The nearest black hole is not a looming threat in the darkness. It is a quiet reminder of how much more there is to learn, and how rarely the universe acts with sudden violence. True cosmic dangers do exist, but they are far rarer and far more distant than our imagination suggests.